So now we move on to sum number 10. In the sum number 10, they have given us the wheelbarrow. So there is a figure of the wheelbarrow over here. Shows a wheelbarrow of mass 15 kg carrying a load of 30 kg. So first thing they have given us mass of wheelbarrow is equals to 15 kg and load is equals to 30 kgf, right, with its center of gravity at A. So yeah, therefore total load is equals to 30 plus 15 is equal to 45 kgf. Now see this. In case of a wheelbarrow, you are supposed to lift that particular wheelbarrow. So when you are lifting that wheelbarrow, the weight of the wheelbarrow will also be a part and parcel of your load. So when you are lifting it up, even if there would have been no load on the wheelbarrow, you will still be lifting a load of 15 kgf. So accordingly, when you are talking about the load, total load, what you are going to lift, it will not be just 30, but it will be 15 plus 30 because of the weight of the wheelbarrow itself. So that will be 45 kgf. And the point B and C, B is of course the fulcrum and C are the center of the tip of the handle, and such that the dimension of AB is given as 20 and AC is given as 40. So it is given that AB is equals to 20. Now this 20 centimeter is nothing but therefore load arm is equals to 20 centimeters and the AC is equals to 40 centimeters. Therefore effort arm is equals to 40 plus 20 is equals to 60 centimeters. Got it? Because the fulcrum is at another one end. See, we see that the fulcrum is over here, right? The load is over here and the effort is over here. So load is at a distance of 20 centimeters. That is nothing but this is A, this is B, and this is C. This AC is given as 40. So automatically the effort arm will be from here to here, that is 60 centimeters. So you need to find out the different values. The first one is load arm is equals to 20 centimeters. Second is effort arm. So yeah, B part is effort arm, that is 60 centimeters. That is what we got from here. The C part is the mechanical advantage. So C is MA is equals to effort arm upon load arm. So effort arm is 60 upon 20, that is equals to 3 centimeters. The 3, sorry, not centimeters, just 3. Mechanical advantage is 3, it has no units. And the minimum effort required to keep the leg off the ground. So you need to find out the effort now. So D is equals to MA is equals to load upon effort. So 3 is equals to load is 45 upon effort. So effort is equals to 45 upon 3 is equals to 15 kgf. So the minimum amount of effort required just to raise it above the ground will be 15 kgf. So this was sum number 10. We now move on to sum number 11. Okay, sum number 11. Figure below shows the use of a lever, wherein they are given you that it is like this, that fulcrum is over here, the effort is in the upward direction, that is E at point A, and at point B is a load which is equals to given as 50 Newton. First of all, say the principle of movement is applied to the above lever. So that is load into load arm. So first one is principle of movement. Now here it is as applied to the above lever. So it will be load into load arm is equals to effort into effort arm. Because it is with respect to the lever. We are not talking about just the principle of movement. To which class does it effort being the middle? So that's why class 3 lever. Class 3 lever. It is class 3 lever. C part. If FA is equal to 10, so if FA is equal to 10 centimeters and AB is equal to 490 centimeters, calculate the mechanical advantage. So it is given that the effort arm is equal to FA is equal to 10 centimeters, load arm is equal to FB is equal to 490 plus 10 is equal to 500 centimeters. Therefore, mechanical advantage will be equal to effort arm upon load arm is equal to 10 upon 500, that is 1 upon 50, or we can say we can keep it 1 upon 50, or it will be 0 0.50 0 10 0 0 0 0 2, 1 upon 50 or 1 upon 50. That is the mechanical advantage, MA. Okay. Finally, the minimum effort required to lift the load. So now we know that mechanical advantage is equal to load upon effort. So 1 upon 50 is equal to load of 50 upon effort. So effort is equal to 50 into 50 is equal to 2500 Newton. So it will be 2500 Newton is the effort required to lift the load of 50 Newton from this point. Clear? We now move on to the last sum, that is sum number 12. Sum number 12. A fire tongue has its arm 20 cm long. It is used to lift a coal of weight 1.5 kgf by applying an effort at a distance of 15 cm from the fulcrum. Find the mechanical advantage of the fire tongue. So first thing is, they are given us that fire tongue is of a length 20 cm. So it is load arm is equal to 20 centimeters. Effort arm is equal to 15 centimeters. Load is equal to 1.5 kgf. These are three things given to us. First thing, mechanical advantage. So MA is equal to effort arm upon load arm, that is 15 upon 20, that will be given as 5 3s are 4 4s are, that is 0.75. That's 0.75 mechanical advantage. We need to find out the effort. So MA is equal to load upon effort. So 0.75 is equal to load is 1.5 upon effort. So effort is equal to 1.5 upon 0.75. That will be twice. So is equal to 2 kgf. Right. So effort required will be 2 kgf is the answer for sum number 12. Are we clear? So these were the numericals which are there for the liver part. So when we see the part of the liver, yes, we come to know that it is the 12 numericals are there, which we just saw. Important part over here is the formula. Secondly, you need to understand the question, and you can make a rough figure in each and every case. You can make a rough figure about the position of the load, position of the effort, position of the fulcrum, accordingly finding out the load arm, the effort arm. Okay, what is the load arm? The distance between the fulcrum and the load is the load arm. Distance between the effort and the load, effort and the fulcrum is the effort arm. So yeah, once you know these points, then get mechanical advantage is the same, and finally with the mechanical advantage you can find out the effort also. So yeah, these are the different examples, not examples, the numericals which are over here. Now we move on to the next part of the chapter, that is pulley. Okay, we'll continue now with pulley. So now what we have is pulley. A pulley, if you see, it is a simple wheel. It's just a simple grooved wheel. A wheel which has got a groove over here. So it will be like this, a wheel complete, a circular wheel, and it will be having a groove like this, a V-shaped groove like this, so that the rope can pass through over here. So because the rope is going to pass through over here, so it will be this way, that if I see that on a side view, it will be of course going to be something, a circular part like this. But when I see it from one side, it will be just going to be a wheel having a groove over here like this. So there will be a groove like this, so that the rope can be placed at this point. So the rope will going to come like this and like this, and this thing is going to be fixed to the rigid support. So this will be connected to the top or the ceiling or something, and this is the center, and this is the rope through which one of the end will be given the load and other end will be given the effort. So effort and the load will be given on the two sides of the rope, and it will be from the sides, it is going to be looking like this. So ye circle idhar hai, and the sides ye rope hai. So this is a side view, we can see that it is connected to, and of course it is going to be connected further to the, so this particular part over here will be connected over here to the rigid support. Okay, so this is a bracket which is connecting this thing to the rigid support. So we see that figure shows a simple pulley. It is a metallic or a wooden disc with a grooved rim. The rim, that is the outer rim over there, it is called as the rim. That is a groove. Groove means a cut, V-cut, or like the cut like this, so that the rope can be passing through it. A string or a rope is passed through the groove at the rim. The disc rotates about an axis passing through its center. The axis is fixed rigidly to a frame by means of nails. So yes, this is the axis. This axis is rigidly supported to the ceiling. So yeah, it could be this way also. This particular part can be shown this way, where it is connected over here, and this axis is connected to the rigid support on the wall, on the roof, or sorry, not roof, it's a ceiling. A single pulley can be used in two ways: as a fixed pulley by moving its axis of rotation unchanged, or keeping the axis as unchanged. So one thing is, I can use a pulley in two ways. Either my pulley is going to be fixed at one point, or the pulley will be going up and down with the load. So there are two ways. One will be a single fixed pulley. A single fixed pulley will be keeping the axis of rotation unchanged. So this is a single fixed pulley, wherein the axis of rotation is not going to change, because this is the axis of rotation. Yes, it rotate karega yahan pe. It is not going to move. The pulley is not going to move except for the circular rotation motion. It is not going to go up and down. It is the load and the effort which is going to go up and down. There is no change over here. So that is called a single fixed pulley, keeping its axis of rotation unchanged, and that is keeping its frame fixed to the position. Or second, as a movable pulley by changing its axis of rotation, keeping the whole frame movable. So then when the whole frame can move up and down, okay, when the whole frame moves up and down, then we call it as a मूवेबल पुली. नाउ अगर मूवेबल पुली का अगर आइडिया नहीं रहेगा तो एक सिंपल एग्जांपल है, इफ यू हैव सीन अ क्रेन, ओके, आजकल तो बहुत सारा कंस्ट्रक्शन का काम चल रहा है, तो कभी बिल्डिंग के ऊपर तुम लोग को बड़ा सा क्रेन दिखेगा और जिसके नीचे यू विल ऑलवेज फाइंड सच काइंड ऑफ थिंग, ऐसा रहेगा. सो एंड देन देयर विल बी अ ट्रायंगुलर पार्ट ओवर हियर, and that triangular part will be having a big hook over here. So such a thing. So this particular thing you will find that ये ऐसे connected है with another pulleys over here, which is connected to the long kind of a bar over here, and then this thing can go up and down. It can be here also, it can be here also, it can go down also, and accordingly the load what is going to be there, it can go up and down over here. So इसीलिए जो ये वाला pulley है which is going up and down with the load is called as a single movable pulley. Of course, this is not a single movable pulley, but example is there because you would have not seen it otherwise. So that's why this is a movable pulley. Okay, this is not single, but it is a movable pulley. Now let us understand a single fixed pulley. So let's see a single fixed pulley first. So a single fixed pulley will be such that there will be a rigid support, a fixed support is here. To the support is connected over here or we can connect it with a hook or anything, but we are going to connect a pulley. So there is a pulley over here. So this is the rigid part of the pulley and this is the pulley. So there is a pulley which is going to be like this, which is having the center over here, and the rope is going to be connected like this and coming like this. So this is how the rope is connected. It is seen that the person, like we can have the load over here, so this will be the load and the person is going to, so this is what the figure they are giving you, the person is going to pull this thing down. So this is the effort. Okay, so effort will be this way, load is going to move upwards. So when you are going to pull it downwards, this is going to move upwards. So you can see over here that the single fixed pulley in which the axle is fixed to a rigid support and an inextensible strong string of negligible mass passes the grooved rim of the pulley. One end of the string is connected to the load L. Okay, you can see one end of the string is connected to the load L, while the effort E is applied at the other free end of the string. So this is the other free end of the string where the effort is going to be applied by this person. Both the load L and the effort E act downwards. So यहाँ पे this is going to, of course, when we talk about this is going to movement. This is what you are shown. What I have shown over here is the movement of the string. But as such, somebody is going to pull it downwards, and here also this load is acting downwards. So अगर हम लोग इसको ये बनाए तो अगर tension दिखाना है, so when I want to show the tension will be over here like this T, and the effort will be over here. This will be the effort this way. So that is going to be this way. The tension over here will be T, and I will take it as T only here. And so the tension on the string, you know very well. Why is the tension on the string? Because the weight of the body is acting on the string, and that's why the tension on the string will be acting downwards. So load is acting downwards, so tension will be upwards. And so on both the load and the effort act downwards. So load is also downwards, effort is also downwards, but the tension is in the opposite. That's the reaction force, that is the tension. On pulling the string downwards by the effort, the pulley rotates and the load moves upwards. So when I pull the thing, so I will show it in a different color that what is the direction of the movement. So direction of the effort is this way. This is the direction of motion. Accordingly, the direction of motion of the load will be upwards. Okay. So on pulling the string downwards by the effort, the pulley rotates and the load moves upwards. The tension throughout the string is T same. It is same. The tension is same throughout. ये पूरा string में the tension is the same. That is in the upward direction. This type of pulley is used for lifting a small load such as a bucket of water or a basket. Note, it is the friction between the string and the surface of the rim of the pulley which rotates the pulley with the string is pulled down. So when suppose this particular thing is very smooth, तो क्या होगा, हम लोग का string जो है वो ऐसे smoothly घूमेगा तो फायदा नहीं है. It has to rotate the pulley. When the pulley rotates, only then our string. So there has to be a friction between the pulley and the string. There has to be a friction between the pulley and the string. Only then the pulley will rotate. Otherwise, what will happen? The string is just going to go like this. This is the pulley and this is the string. Now, if the string is just going to go like this, then no. पर ये अगर pulley घूमने के कारण ये string ऊपर नीचे जाएगा, तो it will be easier movement. Okay. So there is because of the friction between the string and the pulley is going to rotate. Now let's calculate the MAVR of a single and the efficiency of the single fixed pulley. Firstly, we neglect the mass of the string and the friction of the axle or in the pulley bearing. Then in the balance position of the load, we have that load is equal to tension. So if we don't consider the mass of the string, we don't consider the friction over here, we don't consider any of the losses over here, that means everything is 100% ideal. In that case, the load will be equal to, load is downward, equal opposite force, reaction force, that is the tension. So load is equals to T, the tension on the string. Similarly, effort is equals to the tension on the string. So what has happened? Load is equal to effort. So if load and effort both are same, what will be the mechanical advantage? 1. So that is what we see, that the mechanical advantage is equals to load upon effort, which is equals to 1, because load is equals to effort. So we see that load is equal to effort. Thus in case of a single fixed pulley, in the ideal case, the effort needed to lift a load is equal to the load itself. So if I want to have a load of 100 kgs being lifted over here, then this person will have to give a force of 100 kg. So yes, जितना यहाँ पे load है, उतना ही यहाँ पे effort रहेगा. So if the load is 10 kgf, then the effort will also be 10 kgf. If that is 98 Newton, तो 98 Newton ही आएगा. So mechanical advantage is load upon effort is T upon T is equals to 1. Thus, in this arrangement, there is no gain in the mechanical advantage. There is no gain in the mechanical advantage. So there is no force multiplying. There is no gain in speed also, because जितना इतना ये घूमेगा उतना ये घूमेगा. So there is no need of speed also. But the main advantage is the convenient direction. Okay, we need not draw it upwards. We need not do it upwards. So अगर मुझे bucket निकालना है तो ऊपर खींचना difficult है. You need muscle power. Here you can use your body weight to take it upwards. So that's why it is seen that if the point of application of effort E moves a distance D downwards, the load also moves the same distance D upwards. Therefore, DE is equal to DL. Then D is equal to D and DL is also D. Therefore, DE upon DL is also D upon D is equal to 1. So you can see that velocity ratio is DE upon DL, where DE is equal to DL is equal to D is equal to 1. So that's why we see velocity ratio and mechanical advantage both are 1. Therefore, for efficiency will be equal to MA upon VR is equal to 1 upon 1 is equal to 100%. So that is for 100% efficiency, MA will be equal to VR. But in actual practice, it doesn't happen. What happens? In actual practice, there is always some friction at the axle or in the pulley bearing. So the effort needed is little more than the load to be lifted. Thus, mechanical advantage is less than 1, but the velocity ratio is 1. So efficiency is always less than 100%. Now the question arises, when there is no gain either in mechanical advantage or in speed, why is then a fixed pulley used? A fixed pulley is used only to change the direction of effort to be applied. That is, with its use, the effort can be applied in a more convenient direction. So yes, it is more convenient to pull something down rather than lift something upwards. Pulling something down, the gravity is going to help you to do that thing. But when you are going to pull something upwards, at that time gravity is acting against you. So definitely it is going to be much difficult to do that thing. So you need more muscle power in case of drawing something upwards. So by using a single fixed pulley, you are not getting much advantage, but the advantage what you are getting is that it is more convenient. So with this, the effort can be applied in a more convenient direction. So it is difficult to apply the effort upwards to lift a load up directly, but it becomes easier with the with the help of a fixed pulley, because the effort can be applied in the downward direction to raise the load. Further, to apply the effort downwards, one can conveniently make use of his own weight, okay, also for the effort. So that is how we can see that the single fixed pulley has mechanical advantage 1, velocity ratio 1, efficiency 100%, and if it is not 100%, then MA will be less than 1. And mainly it is not a force multiplier, it is not a gain in speed, but it is for only convenience in the application of the effort. Okay, so that was about the single fixed pulley. Now we move on to the single movable pulley in the next video.